they will move apart. Three explanations. Probably forced him to do a fourth one. Well, let's give it a shot. No, let's not quite yet. All right. Just do simple plug and chug. I have 5 microcoulomb charge here. I have a 3 microcoulomb charge there. I'll make it -3. We'll put 8 centimeters between them. 1.08 meters. What is the potential energy of this system? Electric potential energy, it's a plug and chug formula. I got K sub C, Q1, Q2 over R squared. So 9 times 10 to the 9th times 5 times 10 to the -6th times -3 times 10 to the -6th divided by, oops, there's a mistake on the board.
Negative.
Pardon?
The negative.
No, the negative is correct. There's no, it's a scalar, there's no directions. The negative has to stay in. You can't just take it out. But there's another mistake that I traditionally make because of bad habits.
No units.
No, not an issue of units. That's just sloppy. That's not wrong. It's just what I do at the end. Come on, you were introduced to the formula 3 minutes ago and you don't know it by now?
R dot squared.
Energy doesn't have the square at the bottom. I'm so used to doing R squared at the bottom that it just.
You know what? I was actually kind of confused when I saw that R squared.
But you kept this. Oh, you were internalizing. You didn't let it.
Exactly. Just following your advice.
Dad would be proud.
So you said because it's scalar, you have to make it green.
Yes,
And there's no direction.
correct. The negative just means that it's because if you recall, the actual value of the potential energy is not as critical as the change. So I'll make an argument. I'll solve this problem in just a second. Much simpler than this. The intent was the plug and chug. You work through that, you get something spectacular. I know it'll be negative. I got that far.
I did it as 8.99 though.
Okay.
Negative 1.6, rounding, it would be negative 1.69. No,
Just 1.69.
yeah.
All right. Units.
Newtons per meter? No, newtons times meters.
Yes, that would work. Or
I was just saying newtons.
I misheard that. Newton meter, otherwise known as
Joule.
yes.
Darn.
If you're at Newton meters, it's not wrong.
Okay.
All right, so that is the energy. All right, so here's a faster way of doing the exact same problem. When we were doing potential energy with MGH, what did we have to establish?
What?
If I have ground right there and I have let's say that's 5 meters above the ground, and this is a 6 kilogram mass, we'll put this on Earth 2. So G is equal to 10 meters per second squared. What's the potential energy?
We had to establish mass.
Who?
Oh, I don't know.
Yeah. Now for two of you, it was much more recent. I say much more recent, they were in the 8-week version, you were in the 16-week version, so. this- You've had it more recently. However, the potential energy formulas right here are the shorthand notation. If you will recall, maybe it'll come flooding back. It's actually plus some constant. Where potential energy is equal to 0 is arbitrary. If I'm plugging into this formula right here, I made the assumption that the potential energy was 0 joules at R is equal to an infinite distance away. That is the traditional way of looking at it. However, it would have been not wrong if you had looked at this and said the potential energy is 0 because I said so. That the potential energy equals 0 joules at R is equal to infinite. It's supposed to be an infinite.
Okay.
It's not supposed to look like a falling snowman. A fallen snowman. It will have to wait till next week for us to do the fourth way. I'm sorry.
Sorry.
I know. But it's just to keep you pumped up until we get to do it again
And just make it fun.
next week. Was that Abby?
Just make it fun to come back in the morning.
That's right, that's right.
It's the only reason I was here.
It's a cliffhanger.
Yep. It is up there with Who Shot JR. And if you don't understand that reference, ask your parents.
Box off. Box off. Box hanging from cliff. Ideal Corleone.